Hey there again, this is Nate, and today for our tutorial we're going to be discussing the way shutter speed works. Okay, so I have my D90 here, and I'm going to let you guys see exactly what happens in the camera when you take a picture. Okay, obviously that was very fast. If you could catch that quick little glimmer of green in there, that was the sensor being exposed. And I had that at a very slow, relatively slow shutter speed. That was 1/40th of a second. I'm now going to multiply that by several times to 1/4000th of a second, which is as fast as the D90 can go. And now watch what it does. It goes a lot quicker, and you couldn't see any green in there. That's because as your shutter speed increases, obviously the speed with which your shutter opens and closes is increased, and therefore it's much harder to see the actual sensor during this picture, because when the shutter opens and closes, if it's a slower shutter speed, it goes 1 and then 2, but if it's a real quick shutter speed, it just one follows the other like that, and that's called the curtains of the shutter. And that's what opens and closes in there. It's not one unit, it's a couple of different layers called the curtains, which open and close to make your image. So, the way shutter speed works is the faster your shutter speed is, the more the motion in your picture will be frozen. For instance, if you are out shooting a football game, like I do very often, the minimum shutter speed you need to stop a runner is around 1/400th of a second. Okay, I've been able to get away with 1/320th, but for the most part, it's 1/400th. And the other exposure values I use for that is the available light of the stadiums, f2.8 on my 7200 lens, and ISO 3200. And that's the best way to get good nighttime football shots, but you got to have the high shutter speed. See, and that's the problem that I ran into, the problem I had when I was a junior in high school, and I used my D40X SB800 Speedlight and 55 to 200 millimeter f4.5.6 VR lens. Obviously that lens wasn't fast enough to permit me to use 1/400th of a second for shutter speed, and I had to try to compensate with the flash, and that really just didn't work out very well. So the faster your shutter speed, the more your action will be frozen in the shot. But on the other side of that coin is the slower your shutter speed, the less motion is frozen and your images will be more blurry. I'm not going to point any fingers, you know who you are. You little point and shoot people with the cameras that are that big, and the way they sell is they say 14 megapixels, and everybody thinks that's so fabulous, so they all run out and buy them. Those little point and shoots, I'm sure as you know, will blur very, very often. And the reason that is because on those little teeny cameras, their auto exposure controls are not as sophisticated as the DSLRs, and when they are in a low light situation, the first thing they sacrifice is shutter speed. They don't bump your ISO. They tend to leave your aperture fairly moderate, when it could go lower. Most little point and shoots actually have 2.8 on their aperture, but they float, so it'll go from 2.8 to something else. But typically they start down at 2.8. But obviously they will sacrifice the shutter speed as the first thing to go, and that's why your pictures with a little point and shoot are always blurry. While this may not seem like a good thing, however, there are some applications where a slow shutter speed is actually can give you a very cool effect. What I'm going to show you right now are actually some photos that I took with my D90 and my 24 to 70 millimeter lens at a local carnival, of the carnival ride spinning as they're going through their routine or whatever. And what I did was I held on most DSLR cameras here, I'll show you. There's the shutter speed right there, is the 4000. And if you scroll it down, 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 all the way down, there we go, it'll give you a setting called bulb, which means for as long as you press the shutter button, your camera will take the picture. For instance, watch my finger. 1, 2, 3, 4, stop. So for as long as I hold that button down, it'll continue to take the picture, allowing me to pretty much customize a very slow exposure. So I'm going to show you these pictures right now of what you can actually get with a slow exposure, because they are very cool. Okay, so there's one more quick little trick I want to share with you guys before I end here. There's a cardinal rule in photography that says your lens focal length should be equal to your shutter speed. And I'll explain to you what that means. It wasn't a very good explanation, but basically what that means is that if I'm at 24 millimeters on this lens, then my shutter speed should be as close to 1/24th of a second as possible. Preferably faster than that than slower. So in this camera that would be 1/25th of a second, as you can see right there. And as you zoom in, so say I go all the way to 70 millimeters, my shutter speed should then be 1/70th of a second. This camera only goes to 1/80th of a second, so it's a little faster, but that's fine. And the reason for this is that when you measure it out like that, that is said to be the minimum shutter speed at which your images will blur. Okay, so why is this a rule? Because as your photos become more telephoto, as your lens rather becomes more telephoto, it increases. It magnifies the very subtle vibrations of your hand. And when you set your shutter speed to match your focal length, it is said that that is the minimum shutter speed at which you will not get blurry images. Obviously, if you have a VR lens, notice I did not use my 7200 because it is a VR lens, you can go slower than that. It's like 2 or 3 stops slower, I think, so you can actually afford to go under whatever it says. What I would generally recommend is, unless you know what focal length you're shooting at, like for this lens, I would set it on 1/80th of a second and just leave it be the whole time. I wouldn't bother switching down unless you have to for a low light situation, because even when you zoom down, obviously this is a fixed 2.8, so it's not going to go anywhere. But I do really quick want to give you a real life demonstration of what I mean by when you zoom in, your images get more shaky. So stand by for just a second. Okay, so right now I'm looking out my bedroom window, and I'm hand holding my camera at this point. See? Hello, there I am. Yeah, so I'm hand holding my camera. So now I'm just going to zoom in, and I want you to watch how much the shakiness increases. So right now I'm at as wide angle as I can go, and I'm going to zoom in. Watch what happens. Okay, now I'm back to as wide as it'll go. So I'm being totally honest. I didn't do anything except sit there and hold that camera. I support it with the other hand, but I was just holding the camera, and you could see as I zoomed in on the trees, it started to just get jumpy. And that's because, like I said, as you zoom in, your camera is more susceptible to the vibrations just naturally caused by your hands. So that is the reason for that rule with the shutter speed and the focal length. Alright, so I think I've said just about everything I need to say about shutter speed. If you guys have any more questions, you know what to do. I'll get back to you as quickly as I can. If there's anything else you'd like to see pertaining to shutter speed, let me know. I think I've covered just about everything I know about it. There might be something I left out. If you see something I missed, let me know, and I'll try to explain a little better to you. My name is Nate, and I hope you've enjoyed this demonstration of shutter speed.